That IGBT was 650 volt and 60 amp IGBTs. These are good IGBTs. Total 6 transformers. Each transformer drive with the 2 MOSFETs, and we have a total 12 MOSFETs. In the input we have a total 4 MOSFET FHP3205. So 4 of them for reverse polarity, and 100 UF 450 volt, total 3 capacitor in parallel, 24 pieces of SMD diodes. Input negative connected all to the MOSFET source, and then positive directly common with the transformer input. The fuses are useless because it's using a very high rating fuses, 40 amp, 3 pieces here and 3 pieces to another side. Both fuses are on the positive side, useless. If anything get overload or short circuit, the fuses will never blow, but your MOSFET will be definitely blow. So that fuses are useless. That fuse cannot protect your MOSFETs. The PCB prints for the gate signal was weak, so I have no choice to connect the gate pin onto the top of the board and give an external connection. That is a pull driver transistor B772 and D882 in SMD package. If you want to verify the gate signal, you have to go to that pull transistors. If here is signal is good and you're getting a perfect frequency here, so no problem in your driver stage. Sometimes when MOSFETs are burned, IGBT also get blow up, but because it's a very high rating and good IGBT, so nothing is get problem with that IGBT. So just only the MOSFET was a trouble, so I replaced them all, and the signal line was a blow, so I replaced it also onto the top. So that is the complete that board hardware review, and this is 24 volt. And if you have a similar board and some problem, so just simply go to open it and check. The fuses will definitely have a problem, maybe the problem in your internal first MOSFET for the DC voltage input, and then if after that maybe the MOSFET mostly common. If not, then definitely your PWM module, if not then SPWM module. So that is the simple board introduction and the problem. I troubleshoot it and let assemble it and then see how long it can perform again. Today we repair this 4000 watt pure sine wave inverter. The MOSFET is PTP06 and 061. This one is 60 volt and 120 amp. We don't have that one, but we're using the alternative of that one, HY1906. Same 60 volt and 120 amp, just little bit is the difference of the internal resistance. The gate resistor size 1206, that is the size of resistor. So we have a 10 ohm and 10 kilo ohm the resistor. We will change that one also. Here, that was the point. Why this point is getting short, need to check this one. Okay, other all is okay, just only this point. So this all we check. Now no more short. This why I take out all the transformers. The reason is to take out, identify the transformer also. When it get a spark, so the board print also get burned, and the damages is come out from the dual side, from the top and bottom. Here we don't have a signal because the PCB print is here. You can see it's a burn, but resistor I changed ready, so I have to make the connection with the new PCB print. I take out the print and then I connect that to resistor, and there I connect this one, the pin in the middle for as a signal source, and we check signal on the MOSFET gates. So all MOSFETs are chain and troubleshooting is get complete. We make the jumpers for the burn board prints, and now it's time to on this one, and let's see it's blow or it's glow. That is normal spark. Oh wow, thanks God. Now we have perfect voltage and we are successfully repaired this inverter. I will give complete detail now. The IGBT is YGW60N65F1 2026. Good IGBTs. Final testing after changing the MOSFETs and everything, running on 23.6 volt DC and 227 is AC output. Temporary low load is connected, just DC and AC lights, that one and that one. Here is the inverter input and our city grid is off and we are running on the backup of this. And if you don't have experience and you're running with the high voltage AC line repairing like that, so don't do this kind of stuff. You can play with the DC system, no problem, but don't play with the AC system like that, okay?